Hello there! In this video, we would have the solving applications of an ellipse. You see, ellipses are figures with two foci, thus having two focal points for which any ray may be redirected to. This can be observed by studying its reflection property, leading to various practical applications involving sound and light waves. So this can be observed in whispering galleries, just like what we have here, and pools and some medical equipment. Further, ellipses also model gravitational attraction caused by planets. That's why we have elliptical orbits for our planets. Airplanes also utilize elliptical windows for the purpose of redistributing force towards the foci. They are not necessarily circular because a circle has only one focus, which is its center. Rather, we use elliptical windows because this would now distribute the force to two focal points. These are just some of the practical applications of the theories you have studied in this lesson, further proving the usefulness of mathematics in our lives. And to be able to see that further, let us have an example of our word problem. Due to the pandemic, it is imperative to use treatments with the least negative impact on the body. One of these is lithotripsy, a non-surgical treatment of kidney stones. In the initial designs of the urological processes, a patient is placed in an elliptical tub of water where the kidney stone is accurately located in one of the foci to be directed with high-intensity sound waves. Note that a certain tub is designed following the equation 16x squared plus 25y squared equals 400. As you can see here, we have a picture of lithotripsy. So first step, we have to identify the standard form of equation of our ellipse. As you can see, it's not yet in standard form of equation. So we also have to answer the following questions. Determine the values of A, B, and C. Identify the coordinates of the foci where the patient must be positioned. And if 1 unit is equal to 1 foot, will a 6-footer patient fit in the tub? Why or why not? Prove mathematically. Let's see. We identify the standard form of equation of this given here. To be able to do that, let's check. This is 400. And that must be equal to 1, right? So to be able to change that to standard form, we have 16x squared plus 25y squared equals 400. We simply have to divide all terms by 400. There we go. We now cancel out what we can cancel, simplify rather, and we will arrive at x squared over 16,425 plus y squared over 16 equals 1. And this is now our ellipse, or the equation of the ellipse in standard form. Let's identify the values of A, B, and C. We have case 1 here because x squared has a larger denominator. That means 25 is the value for A squared and 16 is the value for B squared. Let's answer this. A now is the square root of 25, which is just 5. B is the square root of 16, which is just 4. To be able to look for the value of C, let's identify, we have C is equal to the square root of A squared minus B squared. So C is equal to the square root of 25 minus 16. Therefore, C is equal to the square root of 9, and the square root of 9 is simply 3. Next, identify the coordinates of the foci where the patient must be positioned. Again, this is case 1, therefore the foci would now be positive, negative, c, or in this case it's 3, comma 0. If 1 unit equals 1 foot, will a 6-footer patient fit in the tub? Why or why not? Prove mathematically. Let's say that we have an ellipse that is horizontal. This is for case 1. We are asked whether a 6-footer patient will fit in the tub. Let's see, how long is this tub anyway? So to be able to identify how long this is, remember that this is now our major axis. Major axis. And what is the measurement of the major axis again? It is 2a. So if the major axis is 2a and our a value is 5, that means we have 2 times 5 and we'll get 10 units. According to the problem, 1 unit is equal to 1 foot. So how long is our tub in, uh, in following this conversion unit? So that means 10 units is equal to 10 feet. Here we're just fitting in a 6-footer patient. So will that patient be able to fit? Yes. And our proof? This would now be our proof that the measurement of the major axis is 10 units. Therefore, the whole lithotripsy equipment is 10 feet. So yes, that's it. See you in the next videos for hyperbola.